So I'm not really sure why I didn't think about this before, but I realized that I could just look for the function, and every time that I run into the macro, like I'm not really sure how to say that in English, but I get confused. And so basically, I'm trying to implement the dragging on the Node 3D. And from the documentation, they talk about this function here, which is a function that they designed to take the to be able to ray trace on the scene and get the events for the CollisionObject3D, which the rigid body 3D inherits from. So basically, you can use this function here if you want to capture events and then do stuff based on whether or not the mouse is clicking or is inside of the CollisionObject3D that you have. Which you have to set the shape on the CollisionObject3D, and then based on the shape, is going to do the ray casting. And usually when I encounter this macro here, I get confused. And because obviously there needs to be something that is going on to be able to, for Godot to be able to do the ray tracing and get the mouse position. So I thought there was something to do with the GD script that is defined on this function here, because this is a macro that they use to define virtual functions that are used by the script instance class that the object class has, which is the class that is responsible for running scripts. So either C# or GD script are going to use the script instance class, and they are going to use these macros to, these macros are the bridge between the C++ code and the script code. So I thought that this is something that I always get confused, because I think that the functionality is here, but then I realized that this is not the case. The only point of the macro is to allow you to call a function if you have a function. So what I assume is happening is that when you have a GD script file and you attach that to a node and you define a function on the GD script file with this name here, it's going to allow you to run the functionality that is defined on the function at this point here. And the reason why I think is like this, because the node has the same thing. So whenever you use GD virtual call, you have to bind the function, and also you have to use this macros here to define to declare the function on the class that you want to incorporate. So these are the functions that usually you run on GD script. There's the process physics process, and it's just like the name of the function that is using here, and then this declares this function here, or defines inside of the object. And then after you do this, then you're able to call GD virtual call inside of any function, and it's just going to call the function that was defined on the class. And this, at some points on the cycle, is going to call the script instance class, which is the class that is one of the classes that manages the GD script class. And the GD script class is the one that parses the file and creates a function. It's basically just a parser. It's going to take tokens, and then it's going to take expressions and form a tree, abstract syntax tree. And then based on that, it's going to derive the functionality for whatever you have on the file. So this is not related to the C++ functionality. It's just if you want to define from the GD script. And the C++ functionality happens before this. I don't know why I didn't think about that, but it has to be, obviously it has to be the case, because this is already receiving the functions. So receiving the arguments. So what I did was just to put this here and then search for the definitions, and then I found a couple of places that it is defined. And I'm going to study those places now, because I'm pretty sure that I found the one that's that actually is gonna be able to ray trace and get the object. And the reason why I want to do this is because the way that I have implemented now, it has to do with the nature of the inputs on Godot that I'm going to show there on the documentation. But basically, there's a hierarchy, and it's very similar to the browser, where at any point on the hierarchy, if you want to the event to stop propagating, you can call a function, and then it blocks, stops the event from going to other parts of the application. So based on this hierarchy, on the browser is very similar, where the event starts on the DOM at the top, the root of the DOM, and then it traverses down into the DOM element that the event was triggered. And then after that, it bubbles up to the other elements. And then if you want the event to stop propagating, you just call stop propagation event.stop propagation, and then it stops the other DOM elements from triggering with the event. It's basically the same logic on Godot. And the problem is that and this is the part that I don't understand very well why they decided to do the way that they did. But basically, they put the picking as the last importance as far as I understand now. So after all the other events run, then it's gonna see if the object picking is triggered, and then it's gonna run that. So the problem with this is that it doesn't allow you to stop the camera events before the object picking runs, because if you do the functionality on the object picking function, so that's the problem. You can't really stop the camera from panning everything. Like if you want to drag the object, it's gonna pan the camera if you have the event on the camera, because even if you stop the camera, the events on the camera, if you stop the camera events on the function of the object picking, it's not gonna work because it's gonna run the object picking part first. So this is the part where the object picking happens, and on the camera I define the stuff on the unhandled inputs. And the reason why I did here for the camera is because I think that's the highest you can go on the camera 3D, because camera 3D is a node 3D. And the other ones allows you to cut the event before the camera. So for example, if you have a GUI element and you want to trigger an event on the GUI, but you don't want the camera to pan, then you can just stop the event, because you can define the event on one of the functions that come before this one, and then stop the event from propagating, and then it stops the camera from running the event. So what I did was basically to put another variable on the camera to stop the events immediately instead of the other methods that they have available. But the issue is not very, it does work, but it's kind of, I don't know. And also there seems to be something wrong with the velocity in which the dragging is happening. And I think it has to do with it has to do with the position that I'm receiving on the function, because that's the only explanation that I think makes sense. So, and it might be because of the way that this function is triggered. So I think a better approach probably would be to just put the functionality for setting the dragging to true or false on the input event function, the function that is related to inputs, and then setting the functionality to move the object or to drag the object on the physics process function, because then it's more likely that the mouse is going to be on the same speed that the object moves. And here it seems that is not the case. So I think the only option that I have now is to study how they do it and then try to translate into and do the separation that I talked about. So change the function, put the functionality that I have there on the input function, and then create another function to run on the physics process to drag the object in the correct speed. And also I have to see if the way that I'm doing the position there to change the position of the object is correct or not. I don't understand why they did it like this, because I assume there is a reason, but it's kind of weird because usually what I would think is that the camera you're gonna use has events, so it makes sense for the camera events should be the last ones, because usually you want the camera to stop before the other stuff, or you could have like options to stop at the same level, but I think that obviously they have a reason for this, and they probably like the way that they are thinking about implementing events is different. So Now you can see when I click here, it does move, but then when it goes out, it starts moving the camera. So I have to go very slow to stop because I had to stop the camera events from happening when the mouse exits the object. And because the object goes very slowly, then it starts triggering the camera. And then it also breaks the situations, I think, is when you click and then like you don't release inside of the object, then I think it bugs because now it's moving the camera. It's based on the way that I did the camera events there. But if I move very slowly here, it seems that, yeah, it works to this side, but not the other one, to the right side. Yeah. And this one is the one that I was talking about, that before, if you don't do the way that I did there, when you slide here, it would drag the camera as well. But since the GUI inputs have higher importance, let's say, than the camera inputs, then it allows you to break the propagation, and then the camera doesn't move anymore. So it allows you to change the physics. And the way that I did this, which is another thing that I don't like very much, is I had to create another variable on the camera 3D. And then I'm just setting the variable to false. So I get the camera 3D from the viewport, then set the variable that I created, and this is on the mouse exit that the function is going to be called here. Yeah, so just gonna, this is the function basically that runs. And before this one, there's another, the one that calls this one, I think, which is the main, hey, what's up? Which is the main function that is going to, because obviously I haven't studied anything of this. I'm gonna do this right now. But this is the main function that's gonna run, I think. But the problem with this one is that I might not be able to, I'm gonna try it now to go with the debugger, but it might not be possible because it might just run when the game starts. And when the game starts, you can debug with VS Code. I haven't found a way to do this yet. I'm trying to build graph visualization on the. It's gonna be in the beginning. It's gonna be something similar to an IDE where I have a side icon bar, and then I have a text part, and then I have a simulation part where I'm gonna show 3D visualizations of code. 3D graph visualizations of code, which is what I was trying to do here on the front end. It's bugged now because I changed some stuff, but yeah, there is a more complicated. There was a more complicated version, but I changed and whatever. But the reason why I didn't continue to do this here is because it's too slow. So I thought that it's probably better to do it with C++. So I'm trying to use Godot to do this now. But now I'm trying to fix the graph, fix the object picking. So I want to be able to drag the nodes. Then after that, I'm going to continue to build the scenes from code. Try to build the C++ scenes from code and then create the other components and then connect them. So basically, I think it comes from here, the position, because that's what they pass there to the other function. This creates this physics, direct space state. They're probably doing something similar to what I was trying to do based on other tutorials, where use the physics server and some other ray tracing classes to intersect the projected mouse position with a plane probably, or with this space somehow. So if I can't see it from the debugger, then what I'm gonna do is just go manually and then try to see if I can figure out and probably translate the parts. I'm going to create another function there, and I'm going to if I manage to do the way that I'm thinking, then I'm probably gonna remove the variables as well from the camera that I added there, because just a duct tape solution. I should probably do this now actually. So I have to remember. So the way you implement inputs on C++ just by defining the input, I think is on the node class. You define a virtual function on the node class, and then if you override the function, then that's the function that is going to call whenever there is an input, and then it's going to send as an argument the reference to the input, I think, and then you can cast based on this logic which input it was. So cast like this. I assume probably there is a translation on C++, so like the classes overload, and then it allows you to convert the type, and then you can call this function to see if the type is valid or not, which means that you can do all the events on the same function. So the same function runs for the different events, but the functionality only runs if the event is valid, if you have to check. Also, you have to set the process input equals to true, otherwise it doesn't run the function. I want to copy this stuff. So the idea that I have is to do the dragging. I think I'm just gonna comment this, or maybe I'll leave the function there. So I'm going to do the flag here. So it's basically mouse up and mouse down. It would be that if you were doing it in the browser. So the mouse down choose when you click the mouse, it's gonna set the flag, and then you do the movement on the physics process part, and then you do the up whenever they release the mouse, which happens here. And I think that if I do it like this, then I can stop using this exit here, and it's probably gonna be better, I think. The issue with these functions here is that they always run when the mouse goes outside of the object, which makes it bug sometimes because the mouse sometimes is faster than the object. I think if I do it, it's on the wrong one. If I do it here, then I probably don't need the things because I can. Yeah, the unhandled input only runs if there wasn't an event. Yeah, if there wasn't an event on the input, I think. But yeah, or you can call, yeah, but I don't think I can't call accept. If you are using a control node, you can call accept event to stop the event from running. But I don't think on the node 3D you can do this. I think this one uses accept events. Yeah. So it might be the same thing, same problem that I have there. Yep. I think that there's probably a way if you're doing on the input to stop. And I also think it's better because it's gonna allow me to do the movement on the physics processing part. Mm. I'm probably gonna have to put arguments here, but I'm not really sure which arguments. This is kind of annoying as well. 'Cause I think I have to ray trace every frame to update the position. But obviously it's gonna depend on the way that they do it there. But I think it's probably gonna be similar if I copy. So like the main thing that I have to get the event position, is the position of the mouse. And this is the part that I'm not sure because if you don't translate, if you don't update the z value of this position here, then the node goes towards the camera, which makes me think that the z is 0 for the event position based on the way that they are translating the mouse position into 3D world coordinates. So that's the reason why I was making equal to the global position of the rigid body 3D. I was making this z equal to the the z from the global position, and then I'm updating the position of the object, which is another part that's kind of annoying because they don't recommend you to do this if you have rigid body 3Ds because it's gonna fuck up this physics simulation. But I think like you can't really move based on the forces because it's not very good. Like it has to follow the mouse position. So I don't know. What I'm thinking is probably the camera I'm gonna receive because it doesn't. Yeah, but even if I actually I can make the camera as a member variable maybe, and then I can initialize the camera on the ready. I think that's probably better because I don't wanna get the camera every time. So So pretty sure that the result comes from here because it passes that on the. I'm probably I guess I'm probably not gonna be able. So one of the things I was thinking about is if I'm not able to see this from the thing because it only is only gonna run when you run the game, and then when you run the game, it's like a different process than the one that VS Code is attached to. So as far as I know right now, the way that Godot works is that when you press the play button to start the game, Godot is gonna use the OS class that it has, that is an abstract base class that is going to be the base for depending which kind of operational system we're gonna use. And then each operational system has a derived class that is actually going to be the one that has the functionality for that operational system to be able to handle everything. And what they're going to do, they're going to build, I think they call the command line, but I'm not really sure. But basically, they run on a different process than the original one, and which is the process that is going to run the actual game. And that process becomes a child process of the main one, which is the one that is attached to VS Code debugger. Because the way that VS Code debugger works is based on the launch .json file and on the tasks.json file. So the debugger is just an interface between the actual debugger, which is either going to be GDB or some other debugger, depending on which kind of operational system you are using, and the user interface. So there's a debug adapter, which is a generic debugger. So the debugger adapter is the bridge between the user interface, which is the buttons you click, and the actual debugger on the background, which is the thing that is running the commands and getting the symbols and stuff like that. So depending which kind of commands you run here, so like the task.json is for compiling the executable, and the launch.json is the responsible for running the executable. So I don't know the specifics very well, but I think that what happens is after you run, after VS Code runs the launch.json, is going to attach the debugger, which I think, I'm not really sure which one it uses on Windows. But the type is the thing that matters. If you're using Windows, you're going to use this type. And if you're using Linux, you have to use another type, which is the type equivalent to the GDB. So obviously it depends on the compiler you are using as well, because the compiler is the thing that is going to create the symbols. So if the compiler doesn't create symbols, you can't attach the debugger because the debugger doesn't know the breakpoints. So I assume that what happens is that it runs the process and mounts the debugger on that process. And there is a way, I think, to do some more complex stuff that allows you to mount to child processes, but the only option that I've seen is for Node.js when you have websites and workers, I think, something like that. You can do like more tasks on this file here, and then it allows you to mount the debugger for any child process as well as the main process. But in the way that I have here, it only allows it's only mounting to the original process, so it's not going to show the steps to the actual game if it runs. And this is the problem because then if the editor doesn't have object picking, then it's not going to break here. So I think it's kind of likely that I'm not going to be able to see, not going to be able to stop here. Then one option would be to change the editor code so that at some point they use a CollisionObject3D, but it might take a lot of time. So I think it might be better to just go over manually. The main things I want is the camera and the position, I think. And the rest doesn't matter that much. So it looks like that. The camera, I think, is the easiest one because I can just call the function there that I'm already calling. And I'm pretty sure it's going to work. I think the camera is easy. So the main thing is just position that I want to know. So maybe I should just follow this stuff here. I'm just going to copy this to the functionality here. So maybe I should, I'm gonna do it on these parts, and then I should probably create another function just to leave this stuff because I'm probably gonna use here and on the physics. So the idea here, I think, is to cast array. Base, you get the object, the mouse position, which is in 2D screen coordinates. Then you translate the position to normalized device coordinates, which is the position that I think shaders, the GPU framework is going to use to clip the space and to do the depth calculation. So it goes from -1 to 1, and which is not the world coordinates. The final coordinates you get if you create a shader and you multiply the position with the model view projection matrix. You're going to get the normalized device coordinates at the end, and the projection matrix is the thing that is going to translate. And then each matrix that is multiplied is a matrix that holds the state for a local reference frame in the visualization. So the synchronicity of all the local reference frames is the world coordinates, which is the official one, and then that world coordinate projected is just multiplying by the projection matrix, which has calculations of the triangle, which creates the pyramid of the the near clipping plane and the far clipping plane that creates the pyramid from the eye that is outside of the camera, and the near plane is the thing that shows up on the screen. So after the world coordinates are multiplied, you get normalized device coordinates. So to go from normalized to world, you have to unproject the coordinates, which I think is basically multiplying by the inverse of the, but I'm not 100% sure if it's the inverse or the transpose. I think it's the inverse matrix of the projection matrix. And obviously on Godot, they have functions that do this already. So yeah, I think what they do is just get the mouse position, then call the functions that translate from screen coordinates to world coordinates or camera coordinates, and then based on that you have the 3D position of the mouse. So it's like the projected position of the mouse, and then you shoot a ray, so you get basically a vector from the center of the camera until up to the 3D position of the mouse, and then with the direct space 3D or with the physics server, you're able to see, because physics server holds the state of all the objects. So you're able to do some checking to see if there are any objects that intersect that vector. And then if there is, then it means that the mouse is on top of one of the objects. So basically use this to see if it's dragging. And I think you can use the same thing to change the position of the object based on the mouse. But I'm not 100% sure. So maybe it's doing here. It's weird. Hmm. So camera. So maybe the conversion is just this here, but it's sending directly. That's weird. How is this possible? Doesn't make any sense. Like based on this, it doesn't make any sense because it means that the position would be just the result without anything done. And that's very weird. So there must be something going on that I don't understand. I think that this situation is when you have the position cached. So when the object doesn't move, it just sends the position that already exists. But it is kind of weird that it doesn't like do anything. It's like how does it create the thing here and doesn't update anything on your gas? I think it's probably because it changes with the physics direct space state 3D. That's the only explanation that makes sense. I think that this is the thing that all the tutorials tell you to do, but it wasn't with this class that I was seeing the tutorials because the tutorials usually the script and I was trying to translate to C++. But even the LLMs, but I think the problem with Godot and the LLMs is that most LLMs are trained on the data that is like from tutorials and stuff like that, and it's basically using GDScript. So a lot of the times they say stuff for GDScript that doesn't accurately translate to C++, or they are trained on an older version of Godot. So this is the class, one of the classes that was in, but is for 3D. I'm not really sure why I think it goes to this one because that's the first definition. There's basically this one that does and this one uses the physics server, I think. But I want to understand how, because I don't need to see there, like the first part, you obviously should implement the stuff, and then maybe later I'll spend time trying to understand how the process works to see like if it hits anything or not. But I'm pretty sure that the stuff that I said before is probably accurate, the way that it works. Yeah, it's weird. So, but how is this possible? Is the thing that is kind of weird to me is that like how is it possible to declare here? Like even if this is the thing that is changing, but maybe it's because this is a singleton or something like that. So if this is a singleton, then but like it's just declaring the type anyway. So shouldn't it be declaring like with the initial stuff here, which means it would pass without anything there on the other function, which means it would send the zero position. Maybe it is what's happening actually, and that's the reason why. Because just when you don't change anything on the object, it just pulls the object through the camera, towards the camera. So maybe it is a vector. But I'm pretty sure that I was printing as well. So yeah, yeah, but I was printing only the Z. So I can try to print the whole position to see what it is. Hmm. But I was printing Z before changing, so it shouldn't be zero. Means it should be there should be like it should be changing at some points. These are There's something going on that I don't understand. Or what instead of one of these functions, maybe it changes like indirectly. So even though it's not explicitly passing this, some of the functions call something that changes this. As I'm gonna ask Grok to see if he thinks that this is a singleton, or I can. There is I think it's register. I think it's probably easier to. It's register core types. I think. Let me just look for this. GD class. No, it's not. This is another register virtual. Hmm. I think it's not singleton now. There is a place where they register all the singleton classes, but I forgot where it is. Maybe it's on the register core types. Oh no, it is. Hmm. Yeah, but it doesn't have here, so I think it's probably not a singleton. Yeah, it could still be a singleton, it just doesn't register on the engine. Oh, so maybe yeah, maybe it is. It's kind of physics server is a singleton. Space. I think it probably isn't if it's initializing here. So I think it's not a singleton, but I'm not 100% sure. So what is going on here? But it has to be the functionality has to be here. It has to start here because other stuff is where it should be, I think. So there. Well, this is using Object3D is a class that they use to keep track of the memory that the objects allocate. And I think that, yeah, it has to do with the object slots, I think. So as far as I understand right now, the way that the Godot works is that they have a memory pool. And that's the reason why they use memnew to allocate memory for the objects. So the memory pool is just a better way to allocate memory for each object because as far as I understand, if you use malloc or calloc normally with the OS, the OS is just gonna allocate memory for each thing depending on the logic that these functions use, which is probably going to fragment the memory. So it's gonna allocate memory in different parts, which is gonna make the process slower because it takes more time to get memory. And if you want to avoid that, then you can use this technique called memory pool, which is you make sure that the use other special functions. I think they use a kernel library, and then they use something, I think an empty string before initializing the object with the new function or new operator. And then that makes the, not sure if compiler, but it basically puts all the objects in compacted, I think, in the same array in memory. And then they keep that track of that on a global object that they have, which is called object slots. And I think that this class is a helper to manage the slots. So it basically works in a similar way that the vector, as far as I understand, the vector on C++ works. So on C, if you're using C, you have to manually reallocate memory every time that you hit the limit for the space that the vector has. But on C++, if you use the vector class, it automatically does that. And it increases based on whatever, I think the standard is just 2x, so it's like exponentially increases. So if you hit the limit, it has, like, for example, the limit is 2 objects, then, and you are trying to put the third, it's going to increase the size to 4, and then it's going to keep increasing twice. And in Godot, they have a lot of classes that they created just for optimizing the way that the memory is managed. So it's basically this class here, this global variable. And also I learned why they use this stuff here. The reason why they use unlikely and likely, even though it seems that it doesn't do anything, is that under the hood, what the compiler is going to do is going to check which it's like a hint to the compiler to help it optimize the branch prediction. So based on some low-level optimizations that the hardware does, and the data path on the hardware is going to, I think it's the intermediate representation, which is the lower level language that the compiler compiles to, is going to have some code that is going to allow it to optimize the way that the hardware uses memory by telling the compiler which branches are most likely to be used. So obviously the ones, it's similar to caching. So the ones that are used the most, you just hint saying likely, and then it's going to optimize the way that the hardware is going to structure, or the way that the assembly language is going to be structured to access the different branches. So the compiler tries to, I think the hardware, either the hardware or the instruction set, probably this instruction set architecture is designed. I'm not 100% sure actually if it is the instruction set architecture or the assembly, but one of the two is going to try to guess which branch is going to be used, and then it's going to keep a cache of the ones that are used most often, and then if it hits that branch, it's going to try to hit the branch that is cached first, and then it's going to optimize it, it's going to accelerate the process because it's using the cached one. I'm pretty sure it's built on the hardware, this branch prediction, so it depends on the hardware architecture, and then the assembly is just built around that. But I think obviously it's gonna depend. It's very confusing. But if you use this on C, and the thing is, it doesn't have to be accurate, but it can help. So you're just basically telling the compiler that this branch is probably not going to be used that often. So I think it decreases the chances. It structures the assembly code in a way that is going to cache the branch less often, or something like that, based on the branch prediction of the instruction set architecture. So what it's doing is basically getting the instance based on the object ID, which is like the index that they use to keep track of the objects in memory, and then it gets the object pointer, I think, from this, and then it's going to cast that to the type, which is the CollisionObject3D, which is the object that they do the ray tracing on. So it returns the pointer to the memory by using the slots, which is a global variable that keeps track of all the pointers, all the objects in memory. So it returns the pointer. So this would be the captured object. And so it's getting the position based on what type of event it was. And it's caching the position. So probably at the end, he's going to cache this. So basically, it's checking to see if the mouse position is the same. Mouse position. Yeah, so you cache this here. So first time it's probably not gonna run this one. It runs this one because it doesn't have last position. So this position is gonna be the one of the event. So based on the casting there, that something happens on C++ that converts the type based on what kind of event it is. So yeah, all these classes here are derived from input events, if I remember correctly. So I think either it's probably the compiler that does this type casting, or maybe I'm not really sure. It has to be the compiler because it doesn't have anything here. I think the compiler figure, or maybe it's the ref function, the ref class. Reference. Yeah, it's probably the ref. Yeah, equal operator. So whenever you do the equal there using the ref, is gonna call this function because this is overloading the equal operator in C++. And then I think that the thing that receives here is the thing that is on the right, which would be the other reference. So it's calling this function and it's comparing the reference. So it compares the pointer. So I think the comparison of the pointer is the thing that the casts the type. And this t here is the type that you initialize the ref with, which would be this one. So it's comparing the pointers, I think. Pointer type. Well, I think that's probably. It's probably so it's changing the pointer from one to the other. I think that's what's happening. It's moving the pointer from the one that it was. The problem is that save this. It doesn't have this function. So I'm not really sure what happens there. Like here. Reference. Or maybe this. So maybe this happens whenever the reference is gonna be another ref. But it doesn't make sense. Or maybe it's on the object class. Could be on ref content. It's whatever. I'm losing too much time on this. I'll look into this later, but I'm pretty sure it's just converting the types. I think it's passing the pointer from the original thing to this thing here, and then this is checks to see if it's a null pointer. Yeah. So if it is a null pointer, that means that the pointer translation didn't happen. So here I think. Oh, so I think this is the one that runs there, not the other. It has to be the other one that runs, not this one. So it runs this one probably, and this is so it tries to cast the type, and then if it doesn't work, it just makes it a null pointer. Reference. So the reference is going to be the object. This is what I want to understand. Reference. Hmm. Yeah, not sure, but whatever. So it's probably gonna hit this thing. Yeah, so this is probably the conversion here. So from the camera, 3D, it projects the ray. And this is the same thing. So it's not passing the interesting the depth. Mm. So what I'm gonna do is just copy this, and I'm gonna put. I'm pretty sure that those are the functions that run there. So I'm gonna put this here, and I'm just gonna set the pointer in the beginning. So this notification here is equivalent to whatever happens on the GD script is basically the same thing. So when you define the underscore process, for example, is gonna run on the notification process event. When you define the physics function, it's gonna run on the same place here. So it's basically the equivalence of the GD script stuff. So I think on the ready, or maybe on the on notification, I think it has to be on ready because maybe the node is initialized before. So as far as I understand now, the way that it works is that on the notification enter tree, it runs right after the node is inserted on the tree, and on the notification ready only runs after all the nodes have been inserted on the tree. But I'm not 100% sure about this. I'm pretty sure that's how it works. So what I'm gonna do is just assign this to the camera there. Okay. And now I'm probably just gonna copy this stuff here. I think that's how they do the conversion. It's probably here. So pretty sure that's how they do it. So hey, parameters is here. Oh, so here is the thing that passes the result. So I think it's not gonna be that hard actually. So they get the space based on this, which uses the physics server 3D. And the space is the thing that holds the state of all the objects, I think. So find row 2D, get space. So this one I can just get the viewports on the other one. Maybe I should create a pointer to everything. The problem with this is that like you have to store this stuff on each node, so it's not very good when you scale. Or maybe I should try to do this thing the way that I was trying to do it before. The issue of doing on the camera is that it becomes harder to get the object. So I think that's the main. But yeah. Uh, it's much better on the camera because you don't have to like do the calculation for all the nodes. Like it seems a waste of time to calculate on all the nodes if you're only gonna be dragging one at a time. So I think it makes more sense to do it on the camera, but then you don't have access to the node, the object. But maybe so if this allows to. Hmm. Also, it's getting the position of the event here. Also, this is from direction stuff for. Also, it gets the z based on the depth here. So the far I think is the position of the far plane on the camera. So it's creating a ray from the near plane of the camera, which is what you're seeing on the screen, up until the far of the camera, which is as far as the camera goes without clipping the objects. So it multiplies that by the depth here based on the direction of the normal. Which I think that the normal is probably representing the surface where the ray hits, and the from is the camera origin, which is just the near plane, I think. The center of the near plane, probably, on the perspective projection. This part I looked into it before. I'm not really sure if I thinking about the correct way. It's getting the viewport size, probably screen coordinates. Viewport size, then camera coordinates from the position. And this part's the one that is kind of confusing. So it's translating from viewport coordinates into this. Doing the dot product, but plus an offset. So this calculation here, I'm pretty sure, almost 100% sure, that this is converting from screen coordinates to normalized device coordinates. So this is the conversion here. Maybe it's everything actually. I think like it's just creating a vector normalized device coordinates and normalizes here. Because this one I've seen many times on other applications as well and other stuff that I did before. So dividing by the width, multiplying by 2, like this is very familiar. So pretty sure that this is converting to normalized device coordinates. So it takes this. So I think it's taking on normalized device coordinates, right? And then it's getting on the camera. But the thing that I'm not 100% sure is whether or not this is on. I think it has to be on camera coordinates. I think that's the only thing that makes sense, because otherwise, yeah. Oh, it looks like it's getting the global. So it's on global camera coordinates. So it's not on the relative camera coordinates. It's on the global camera coordinates. So it's converting the mouse position from the viewport into global camera coordinates, I think. and it's getting normalized. So like this is the normalized vector, so it doesn't go all the way. So it's just like a unit vector. So it's from 0 to 1, and it just encodes the direction of the vector from the camera position up until the global camera coordinates of the mouse position. So it projects the mouse position from the viewport coordinates, which are screen coordinates, I think, into normalized device coordinates, and then it projects onto the global camera coordinates, and it gets the vector that has the direction by normalizing. Then based on this, is going to multiply by the depth var, which is just the far points on the camera. Which it has the, it's basically the distance of how far the camera can go. And then it's just, it's increasing based on the from, which is just the origin of the camera. So yeah, I think I understand very well now. And then it's gonna send this with the result there, which created before, to this, and this is gonna use the space from the physics server to intersect the ray with the. So this is one of the functions that I'm interested in understanding. But it's gonna intersect the ray with the. Uh, it's gonna intersect the ray from the camera with the space and the space state, and then it's gonna capture what objects were hit based on this, I think. And probably it's gonna update this inside of this function, I think. Yeah. So the result's gonna have the position. So I think all I have to do on the other one is just extract the parts that are important here. And then I have to think about what is the best way to organize this. If I should put it on the camera or try to put it on the object. If I put it on the camera, I'm gonna have to think about how to get the collision. But maybe it gets from the results. So maybe it's better to try to do it on the camera. A result.collider. I think I'm gonna do that. I'm gonna try to do it on camera again. First time I tried to do it on the camera, and then I thought it might be better because it might be better to do it on the node because of the CollisionObject3D function. But if I do it directly with this stuff, then probably better to do it on the camera. So I'm gonna test first on the GraphNode 3D, and then if it works, then I'm going to translate this to the camera, I think. And then it becomes a lot easier to stop the camera from moving if you're dragging the object. I'll be right back. So I think that's what I can do. I don't even need to. I'm, I should probably copy this stuff. So let me think this. So I think probably what I should do is just copy this stuff here. I should copy this part here, there. Thinking whether or not to make these variables of the class or initialize them on the beginning because I'm probably gonna use the thing is I'm not gonna use here, so I think I should probably just test to see if it works here, and it doesn't matter what I do. And then if it works, I just move this to the camera 3D class. So I need the position. It's gonna be against relative position. So this checks to see if fix this. So now here, so maybe here I can put, I think I'm not really sure if it's gonna work. If I do, I wanna check to see. I'm gonna check to see if this collider is the same as the instance here. But I think on the camera it's not gonna matter. So I'm gonna leave it like this, I think. So if this happened, then it's dragging. So I'm gonna do like this now, and then on the camera probably. So the camera, I think on the mouse move you can use get relative to get the position, but I don't know very well how it works. I think it gets the delta from the previous position and the current position of the frame. If you don't do that, then you have to. So either I can use the use the get relative to on the mouse move to translate in the same way that they are doing here, and then update the mouse position. Actually, I'm not gonna be able to do this because I want to do it from outside. So maybe I'll have to. But how I'm gonna project the position? Hmm. So I have to think about how to get the mouse position on the physics. I think from GDScript you can use get global mouse position on the physics process, but I'm probably maybe I can try to do something like with the viewport. Get mouse position. So maybe I can get the viewport and use this function here. Then from this position I change. So it probably is better if it's always confusing to me to get the delta because I always like it's kind of annoying, but so I think I should maybe I should probably not do anything here because I'm gonna translate to the other stuff. And here will be position. And then on the physics process, you use this one initially, and then you assign this one to the current one, based on the one that you get, I think. Maybe you don't need to. So this should be. So I'm gonna press F5 a bunch of times to see if it's gonna go over that function. But it's probably not gonna go over. So, and I think that it is correct the way that I have there. So I'm just gonna stop this one and then I'm gonna compile again and then try to run and see if I get the position there. So if I get the position, then I think what I'm gonna do is just move this stuff to the camera again, the camera class, and then do on the camera. Yeah, it's not running the function. So the problem is, oh, so runs here. Hmm. Hey, what's up? And even though it's running here, I think it's not. I'm not gonna be able to see because it's not gonna pick any object and it's gonna keep stopping. So it's not gonna allow me to put the mouse over the object. So unless I should probably remove this and then it's not gonna allow me to see the full thing. Uh, someone's asking should I go into coding? It depends on. Uh, I think that it's impossible to answer this question actually. Like only you can know what you should or shouldn't do. But I think that I can only speak for myself in the way that I think. So in the way that I think it makes sense to go into coding even if AI is gonna take over. Because the way that I view life is that you don't have a choice but to improve forever because that's the nature of space and time. So you're always gonna be forced to improve. So you have to pick something that you think that like is a high priority for you and you enjoy doing, and that there's a like more a high probability that you're gonna be able to sustain yourself or make money doing it. And I think that based on the state of things, is most likely the case that uh, everything's gonna be converging towards AI in the future, and there is no escape. So like the safest jobs would be on the short term. On the short term would be to work on something that you do manually because robots are kind of bad with that and it's kind of harder to scale robots. But those jobs will eventually be taken away as well. So like the last thing that's going to be taken away by AI is going to be the power of the mind. So like being able to handle very complex, abstract ideas. That's the last thing that is gonna go. So basically being an entrepreneur. So creating stuff, building stuff and building businesses is the last thing that is gonna be automated because it's the hardest thing to do. So because you don't have any options to avoid this stuff that is happening, then it makes sense that the only thing they can do is just try to become as best as possible using AI to build businesses. But obviously that's not scalable and it's probably gonna lead towards destruction because you can't it's gonna follow the Pareto distribution on human beings, which means that even if everyone converges to building businesses at some point, uh, like it's gonna be a small percentage of people are gonna take all the money because they're more effective. But that's outside of our control, so the only thing you can do is become better. So I think it makes a lot of sense to try to become as best as you can as using AI because understanding how to code and using AI, understand the laws of physics, because that's the nature of space and time. So you can't avoid. And it's not about the outcome because you don't control the outcome. So you can't think about the results because it's outside of your control. So you have to think about the process and who you want to become because that's how reality most likely works. You are always in the present, and then you create the illusion of past and future based on the reference frame of your identity, which is a paradox itself. So this is the thing that happens after you click there. It's gonna open a process to run the game, and then it's not gonna allow me to see this step over after it starts the other process. Yeah, I was reading the Twitter today, and there was a post of a guy that he's 27, and he was asking if he could become cracked, like really good at programming by starting at 27. And I think it's kind of the wrong mentality to have, and like it makes a lot of sense, and there is some degree of truth to that, but it doesn't like it's focusing on the result, and it's the same thing with money. Like a lot of people, they focus on the amount of money they want to make, but the reality is you don't have control over the amount of money you want to make, because money is a side effect of systems. So the businesses are at the cause, and the result, which is money, is at the effect. So the way that the market economy works is that you have supply and demand. The supply is the limbic system, which is the animal brain, the reptilian brain that human beings have, which wants the Maslow hierarchy of needs. So the Maslow hierarchy of needs is the gravitational force of the computation of the human beings that the market economy runs on. And then the businesses, which is the supply side, is going to be the computation that is done by the network to fulfill the desire of the limbic system. So the market economy is basically running the computation of the Maslow hierarchy of needs of human beings, and produces technology as a byproduct of that. So all the businesses are trying to increase profits, and the way that they do this is by feeding off the limbic system. So they are constantly trying to hack human bodies to gain more power, because if they are more effective at pleasing the limbic system, they gain more money. So, and that's the cause of the way that things work. And then the money is going to be the consequence of how effective you are at pleasing the limbic system. So basically catering to the Maslow hierarchy of needs that all the human beings have. And to become good at something is basically going to be the same idea, that you can't really determine if you can become cracked or something or not, if you can become very good at something or not, because that's basically genetics. So it's outside of your control. So the reason why people spend a bunch of time thinking about this is because their limbic system is trying to trick them into not doing the work that deep down they know they should do. So there is like called rationalization. So it comes up with ideas to tell you to not do things because energy is very important. So everyone's trying to save as much energy as possible. And the way that the body does this is by telling your mind that there's a bunch of different reasons why you shouldn't do something. So it all comes down to the hierarchy of importance of your values, because that's the only thing that you're going to be able to use to determine whether or not a thing is important enough to you to do. And that's going to depend on the stuff you're naturally curious about, combined with the stuff that realistically increase the probability of your survival. So it's like the middle way between the limbic system, which is biased towards the now, to maintain yourself alive now, and for the prefrontal cortex, which is your imagination, your idea, which is the projection of yourself into the perceived future you have now. And the balance of both of these things is going to be dependent on the circumstances of the world. If you live on a scarce environment, it makes more sense for you to cater towards your limbic system in your animal self, because whatever's happening in the short term has more importance. So that's the reason why most people think like this, because it's just natural selection. But if you are in an environment that you have relative abundance, then which most of the people in developed worlds are, then you should probably try to cater more to your prefrontal cortex, which is long-term planning. But with AI, it's very unpredictable. So I think that either way you think, it's kind of pointless because it's outside of your control. So it boils down to what do you like to spend most time doing, and how can you incorporate AI into it? And I think that all the options that I think about is probably like is like an obvious decision that the only thing you can do is try to learn how to code. Start coding to make Roblox games. Yeah, that's nice. If you enjoy that, then you should do that. So detach yourself from the outcome and focus on the stuff that you wanna do. Like what kind of systems I want to build, and why do I want to build these systems, and what's gonna be the byproduct of these systems being built. And anything you're gonna do, you're gonna become a fractal. So because that's how reality works, I think. So and like there is a horizon of computational irreducibility, which is a byproduct of your awareness of your experience of the present. So you're always going to be trapped by that boundary, which is the boundary you can't really compute anymore. What's going to happen? So the best you can do is just look at the current state of whatever's happening, and then ask yourself, like, what are going to be the consequences of me doing this, and how it's going to affect everything, and try to become more and more aligned, of trying to become like have harmony with the environment. So becoming someone that creates an environment where you can have harmony. Oh yeah, I didn't compile this. So yeah, it doesn't do the breakpoint because it opened a different process. So I'm gonna stop here and I'm gonna try to compile and then see. I think like this is one of the reasons why I think that's, you know, other people say this as well, that the most dangerous people in the planet are intelligent fools. And I think the reason why is because the reason why these people gain so much power is exactly because they are unbalanced, which makes them seek more. And then because they gain more power, because they're hacking the limbic system of everyone else by building companies to exploit the human body, they gain more and more power, but like at the fundamental level is imbalance because the structure of the system is not self-similar, which means that the nature of the incentives is naturally unbalanced. So the cycle of creating technology as a byproduct of the market is self-destructive by nature because not self-similar. So it means that it's not fractal. And I think that that's the reason why it generates a black hole because you're always trying to get more and more stuff. Exactly because you are imbalanced. So you're addicted to power and control. And then that generates an environment where at first it looks like you're winning because you're getting more stuff, but it goes against the nature of space and time itself. Because if space and time was fully centralized, you wouldn't have an observer, because you wouldn't have boundary between the observer and what's being observed. Deep down, everyone and everything is always chasing the same stuff, which is should be unified with the whole, which is where all the addictions come from, I think. But it's just human nature. So if you understand that, then I think that it makes more sense to try to become more, try to create a reality where you have a network that is balanced with the environment, regardless of how much power the nodes that are part of the network have. Because then it doesn't matter how, because then the goal stops being acquiring a bunch of stuff from the environment. It becomes more achieving a harmonious exchange between what you perceive to be yourself and what you perceive to be the environment. And that's sustainable in space-time. But I think that it's always going to be a convergence, because this is something that I realized as well when I was studying hardware again, which I didn't fully understand. Like I didn't know very well what was information, but now I think I understand. So information is basically a tree, a binary tree, because information is just a decision. So based on the decisions, you have the probability of what's going to happen. So the leaves of the tree are the least likely events, because you need to take more decisions to get to them. And the size of the tree encodes the amount of information you have. So it means that the least likely something is, the more information you have. And that's the measure of entropy and the measure of information. So based on the way that I was thinking, I was seeing people explain, which I think it makes sense. But this is the thing that is kind of confusing to me, because the way that I usually taught is that they are inversely correlated. So like but maybe it makes sense. So like the more entropy you have, the more information you have as well. Because it can only have very unlikely events if you have a lot of entropy and information. So like there are mirror symmetries of each other, and the structure of the tree determines the perception of a reference frame, I think. So this means that the nature of space and time is to become as unique as possible, let's say, because that's how information grows. So like space and time itself is the growth of the tree over a reference frame, which just means that it's creating the most unique possible situation all the time. And that's like that's what time is in itself, because it's created through the present. It's a reflection. So that means that the essence of life is to become as unique as possible on space-time, I think. Which means creating more and more information, which means that you're never gonna have retirement or anything like that. And seeking the maximum control is also like a vicious cycle, because it's incongruent with space and time. Seeking the maximum control is going against the nature of information, because what you're subconsciously trying to do is to minimize the chaotic nature of the universe, which makes sense from the body's perspective, because the body is always trying to maintain itself. And I think that's the reason why the market economy converges through this vicious cycle, because it's unscalable in space-time. So companies hack a limbic system and creates this vicious cycle where most of the population are incentivized to not think critically and to save as much energy as possible, because that's more effective. That's how you create hierarchies. And the people in power are incentivized to keep hacking them and keeping them dumber and dumber, because then they become more easily controlled, which means that you have this vicious thing, which is feeding the machine, which is the companies. And that's the nature of the incentives. It's the incentive structure of the market economy, because the politics is unscalable. And that creates a black hole, I think. Because the people, one company gains more and more power because follows the Pareto distribution. And it does that because it's subconsciously trying to survive, which means maintaining its body, but it's not smart, or it's not wise enough to see the connection of its body with the whole, because it doesn't want to make the sacrifices to not gain as much as possible. So basically, it becomes greedy. And the reason why is because the more intelligent something is, the more capable it also is of rationalizing its own intelligence. So I think that the two things are not, they're probably inversely correlated to a certain extent, I think. The more intelligent you become, the harder it becomes for you to understand the connection of the whole, because it's like a pyramid. So intelligence is like a sharpness. So it's more depth, I think. Like it goes faster, but it doesn't have a lot of surface. And the nature of society is the hierarchy, because it's going to encode the computation, which is the frequency that you go from surface to depth over space and time. So it's a byproduct of the human network, I think. The way that the brain works. The frequency of the computation of the brain creates a black hole over time, if it dominates the environment. So I think the only way that makes sense to solve this is through the blockchain or something like that. So changing the frequency of the computation that the market economy runs on to a more balanced thing. But the tricky thing is that it has to be more powerful than the other network. Otherwise, you're just gonna lose the arms race. But I think that you should. I think that's just a natural evolution of space and time. Because even if you humans die, because like it just makes more sense that the network that uses more intelligence and wisdom is going to be more powerful than the one that is just hacking the limbic system, because it's going to be able to do more long-term planning. But I think is speaking these things is also easy, and building is like a lot harder. So nice. So it is catching the thing. Mm. So I guess yeah, this. So what I'm gonna do is print the. Before I change for the camera, I'm gonna print the position of the object as well and see if they're the same. The thing is kind of annoying is I don't remember if like I don't know if I can put strings here. Yeah. So I think I can. So basically the. Was global position the one I was using? I think it makes more sense to be global because the camera is going to convert to global coordinates as well, I think. So it projects the mouse position based on camera global coordinates. So it makes more sense to use global for the object. So the global coordinates of the camera is going to be, we'll do is quite wrong. Because this part's the one that I had, it was the most confusing to me in the beginning to understand how this works, the coordinates. And I did a live stream trying to explain as well. But it's basically, so each object you have, based on the matrices, you can create another coordinate. And then they're all synchronized based on the, so let's imagine that this is the global coordinates. And then the camera is at some point in space. So this X and Y, Z position of the camera, so on the camera local coordinates, the position here would be 0, 0, 0 on the, on here. But on the global coordinates, it's going to be something else because it's the distance between this reference frame here to this point here. So the global, I think what is happening there is that it's getting the positions based on the global coordinates. So it's relative to this. It gets the camera, the mouse, the projected mouse position from the camera's perspective based on the global coordinates, which is this one. So this wouldn't be a 0 for the camera. The origin of the camera would be different on this coordinate thing. It would be like whatever value here. So this would be this coordinate system, the origin of the camera here. And but this is yeah, and the object would be like somewhere here. So I think that I think it gets the projected mouse position in relationship to this coordinate system here, using the camera functionality. But I'm not 100% sure. And so for that reason, if you get the global position if you get the local position of the mouse, then it's gonna get relative to the object, which is another reference frame. But if you get the global mouse position, it's gonna get in relationship to this reference frame, which is the global reference frame. So I think that it makes more sense to use global there. I think probably what I'm gonna do is create another function on the camera, and then I'm gonna accept the results as an argument, and then I do this calculation. Because the thing is, I probably have to do this every frame, every physics frame, because it's the only way to get the position there, because you have to intersect the ray, I think, of the mouse. So I'm contemplating whether or not it makes sense to try to do this on the physics process or not. Or but maybe I don't need to intersect. I think I'm gonna try this first. So get the viewports, and then you use the viewport to get the mouse position. Then you project the position based on this. But the problem is, yeah, this is the issue. Is like if you get the camera far, I think it's gonna get it's not gonna get the accurate object position. It's gonna get the position based on the ends of the far plane of the camera. So it's gonna be the wrong position. It's not gonna be the mouse position. Maybe I can use can we just multiply based on the object z. So instead of doing like this, I just do the from plus the direction times the object z. Maybe this the way. Because then I avoid using this stuff here. Also, I don't understand why sometimes it does this stuff here. Like, it explodes. It has to have something to do with the spring force, but it's kind of weird because it only does this. It only does this sometimes. So it's on different coordinates. About it today. So maybe it's wrong what I was saying there. I have should be wrong. So the question is how to translate from the position from the object to the same as the mouse as the results, or translate the result position to the mouse position. That's the question. So let me try the position to see what happens. If I can translate the vector, so it looks like it's not only the like is because initially I thought the z was the thing that was wrong, but I think that it is the whole vector based on the stuff there. So what is happening is just different reference frames that it's getting. So the result position is on a different coordinate than the global position from the object, because obviously they have to be very close, if not the same, because the mouse is supposed to be the ray tracing is supposed to get the heat on the object. I think this last thing that I'm probably gonna do the rest of the stuff off stream. So I'm just gonna print this and see what happens, and then I'm going to think about how to translate one to the other. Yeah, the thing is that I have to. So yeah, so maybe I can create a function and then call the function to. Hmm. I'm trying to think about a way that I can do so that I can step over the stuff to see exactly what are the values and what is going on. But I need to understand how the conversion is, like what is going on here. Maybe I can ask Grok or other. Yes. Shape points. Hmm. So I think it's probably getting from the relative position. Them. So based on this, it gets the relative position, I think. It's getting from the transform of the object. I need to clarify this again. It does a cross product, but I don't remember really well what is the physical significance of the cross product. So the videos, like, it's kind of hard to remember. There's something to do with the cosine, I think, and the magnitude. So actually, maybe I don't need the position, actually. Because I should probably just... the thing that I have to do is just translate the mouse. So I can do the stuff that I was talking about. I think that it doesn't make sense to move the object based on this position because it's just going to be the position of the object itself. It's just tracking to see... so I think the correct way to do it is you do this stuff here to see if it hits anything. But on the actual movement, you just use this calculation here. And then you just change the depth so you have the position of the object. So the question is how to translate how to get the object position in the same coordinates as these vectors are. And then how to change the object position based on that. So I guess obviously the easiest thing to do is just to test. So just change that far to the the z position of the object. So probably that's what I'm gonna do. I'm gonna do on this class first, and then I'll do it on the other one. And now it's closer, but not the same. Yeah, it's very far. But it might be because it's on the surface. So the result position is hitting the surface and not the object. No, but this is very different. So it's something else. Yeah, but like I said, I think it's probably better. So what I'm gonna do is just try to... I'm gonna create another function. Add this one. And then I put... I don't think I'm gonna put anything there. This gets viewport. But this one I do something else. But maybe I do get transform. Dot z. I think this one is basis. Yeah, basis. Transform. I do the basis. Let's see. So basis. So maybe just the transform. As basis is going to be the matrix, 2 by 2 matrix that holds the states. The transform origin z. I can try this one first. So here, do the same calculation there. I'm gonna print this as well. I have to do if dragging, then I do. So I can try this one, and then I call this on the physics. I'm already doing there. I think. So I want to test this, and then I'm probably gonna stop streaming and then think about if it doesn't work. I'm gonna think about other stuff, and then if it does work, I'm going to probably move as well off stream from this class to the other to the camera. So that should be the origin. I think it returns a pointer. No. The problem is, I think. I'll be right back. And so it's clearly wrong, but it looks like it's working fine with the movement, which is nice. So all I have to do is fix the position, fix how the position is being done. It's also weird that it's like pulling everything immediately to the same place. So I think that this has to do, but it's kind of weird because I'm only hitting one thing. So, hmm. It's pretty nice that it seems that it's working with the speed. So I think this way it's gonna work. I just have to figure out how to put the same scale of the coordinates. Like, what are the methods what are the functions that I can use to move the node in the correct way? The thing that is kind of weird is that's putting all the objects in the same place because it should be only triggering the events on the one that is intersected. Hmm. So the question is, it could be because of the physics simulation. Oh. So obviously it's setting the drag to true on all of them. Well, I think it's because if it finds one, I'm setting the dragging. So like the event runs on all of them because all of them have the function defined, and then it sets to true because one object was hit, and then because it was set to true, then all the nodes are gonna run this. But I think moving to the camera is gonna immediately solve this. So on the camera, what I should probably do is just keep track of I create a variable, a pointer on the camera, initialize null pointer, and then I do the same stuff here, and I just assign the object, which was the thing that I was trying to do before. And then I just set, I put this variable on the camera, and then on the function that moves, I'm gonna move this function to the camera as well, and then here I get the transform from the object on the collision. So that should solve the thing, but it's still, I don't think it's moving in the correct way. But maybe it is actually. I think about it, as it is following the mouse. I think that this should solve. If I move this to the camera, it's probably gonna solve everything. I'm gonna stop streaming now, and I'm going to move this stuff to the camera, and I'm gonna test to see if it moves correctly. And this makes it automatically stop the camera from moving, I think, as well, because now I'm defining everything on the inputs. So yeah, on the camera, I'm gonna do the same thing. I'm gonna put this drag node function on the physics process, and then I'm just gonna make the events of the camera dependent on whether or not it's dragging, and if it is, then I stop the other ones. So I'm gonna do that upstream. So see you next time.